This is problem number 5 from section 8.1. It says the figure shows the bearings of a ship on a lake from 2 observation points located on a straight shoreline. The bearing from the first observation point is 54.4 degrees, and the bearing from the second observation point is 325.3 degrees. If the distance between these points is 20 miles, how far is it from the ship to the shore? So they want to know how far is it from the ship to the shore. Well, this is the shoreline. So I'm going to draw the shoreline in green. Now we know that this thing is, the ship's out at sea. This is the shoreline. If they want to know how far it is from the shore, we're really looking for that height there of this triangle. So we're really looking for the straight line distance from the shore to the ship. But we need to figure out, in order to figure this out, we're going to need to figure out maybe side A, might be side B, or side C. Now we already know side C is 20 miles, so I guess we don't need to find side C. But if we want to be able to do some SOHCAHTOA with a right triangle, we can either use this right triangle or this right triangle. Either way, we're going to need a side length, so we're either going to need A or B. So the first thing I'm going to do is I'm going to start out by drawing this real quick. Just a rough sketch. I know I'm looking for this. This is 20 miles. I know that this is B, this is A. And then I'm going to label some angles in here. Now, this is 54.4, so angle A, I'm going to write underneath, angle A is 90 minus 54.4. And 90 minus 54.4, 35.6. So this is 35.6 degrees. I want this angle. Now this goes around 270, and then from the x-axis, that's the angle we want. So we want to subtract for angle B. Let me write this in here. This is 35.6 degrees. We want angle B to be 325.3 degrees minus 270 degrees. So angle B is going to be 325.3 minus 270. That's 55.3 degrees. So this is 55.3. Okay. I need to either find B or A, and they give me C. I come to my law of sines. Put that out to the side. I'm going to try to find B. So I'm going to use, in this case, I'll use B and sine B. And let's see. Well, really, before I start that, I need to find angle C as well, don't I? Yeah, I better find angle C. Let's go ahead and do that. Angle C, if I know these two angles, angle C is 180 minus 35.6 minus 55.3. So angle C right here is 89.1. Now that's the one we really wanted. If we know 89.1, we have this opposite side. So we're going to have to use C over sine C in this problem. Let's go ahead and start it. So 20 over sine 89.1 is going to equal, and I'm going to go for B, I said earlier. So B over sine of angle B, which is 55.3. Multiply it across, I get 20 sine 55.3 over sine 89.1 is B. So let's go ahead and plug that in. That's 20 sine 55.3 divided by sine 89.1. and I end up with 16.4449 miles. So this side B is I can write that up there, 16.4449 miles. Now I can use SOHCAHTOA here to find this side, because I really want to find this height right here. I want to find X, we'll say. So I know that this angle is 35.6. That's the opposite side, that's the hypotenuse. So I'm going to say sine of 35.6 equals X over my 16.4449. Multiply that across, you get 16.4449 sine 35.6 is what X is. Plug that in there. And you get 9.57 miles. So the ship, this distance here, is 9.57 miles from shore. And that's the answer to this problem.